I'm very delighted to bring in our next speaker. Monika Stasna is product owner at Alplan Slovakia and currently focusing on steel constructions. After graduating as an engineer in building construction technology from Slovak Technical University in Bratislava, she worked in an architectural office. In 1995, she joined Alplan, initially for quality insurance. Today, she's product owner. Monika, welcome to today's launch event. In your session, you will present the newest developments on mark numbering within Alplan 2025, not only for steel, but also for precast elements. So let me ask you a question before we go into the software. How do users benefit from the improved mark numbering for steel and precast elements?
Also, hello from my side. Thank you for your question. Users can work with the mark numbering easier and faster for steel object. And there was done also first step to apply new mark numbering system for next type of the Alplan objects for precast objects.
Okay, that sounds pretty interesting. So I can't wait to see how the optimized mark numbering looks in the brand new version of Alplan. Monika, you have my attention.
Thank you, Tim. For version 2025, we introduced a new functionality for the mark numbering. When you start the function, you will see a palette with 3 new properties. Every property has its own information button with a short description. As a first improvement, I would like to introduce the possibility that now we can exclude the drawing files which should not be considered for the recalculation of the mark numbering or for the creation of the new mark numberings. Already existing mark numbers in these drawing files will be ignored. If you decide later to again recalculate these drawing files, you activate them and they will be considered again. The next new property is the possibility to use again the mark number which was used before but currently is not used. So, for example, I would like to generate the new mark number for this object. So when the check is not on, I generate the mark number. On the next new free mark number was set. So it means now there is a B11. But I would like to use mark number 4 because we can see that mark number B4 doesn't exist. So we can set undo step and generate the mark number again. Now I activate this possibility, generate the mark number. And we can see also in the object palette that the free mark number was used. Then there is a possibility that now we can recalculate all drawing files through the whole project if there are some incorrect mark numbers. For example, I change this object, I change attributes which should be considered for the recalculation of the mark number, for example, material. I set a new material, so then we will see the information about incorrect mark number in notification center. I start the palette for the mark numbering and I click only the recalculation. So now the recalculation is done through the whole project. After confirmation, so you can see that now there is a correct mark number. Then the new functionality of the mark number is used since version 2025 also for the precast objects. So here is a simple example. I select the precast object. I define a schema for this object. So for example, I set $8. Now I start the recalculation. And we can see in the object palette that the new mark number for the precast objects was set, but we can check it also directly in the palette for the precast objects. So here we can see that the new mark number for the precast object was set. Okay, so that's all from my side. Back to you, Tim.
Okay, thank you, Monica. Good to see that improvements on mark numbering have been implemented in the latest version of Alplan, but I'm sure you have further improvements to the mark numbering function in the pipeline. Therefore, I would like to know which future developments our users can expect.
Our customers can expect extended functionality because the development is still in progress and we are still adding next new features. Later, it could be applied to any type of objects in Alplan.
That is a pretty promising outlook, I'd say, especially to apply to basically every object out there in Alplan. Monica, thanks once more for being part of the launch event. It was a pleasure to have you on board. Take care and see you soon.
Thank you.
Okay, let's turn the subject of precast elements and bring in my colleague Fabian Scheller. As product manager at Alplan, Fabian Scheller is responsible for the development and the implementation of new software solutions that meet the specific requirements of the precast concrete industry. Thanks to 16 years of experience in various positions at Alplan Precast, he has a deep understanding of the technical aspects of precast concrete production and related software solutions. Therefore, he is the perfect match to introduce you to some new features of Alplan Precast. Fabian, you will show us today how to create free-form shaped precast elements in a quick but yet precise manner.
Okay, let's have a look on the newest functionality to improve the work with any kind of complexity. I would like to start with the main highlights for reinforcement detailing inside of Alplan 25. There is a new function called place bars along any surface, the possibility to unlink area reinforcement, and the improvements of direct object modification for easy adjustments. Our example is a complex balcony with the new functionality place bars along surface. It is extremely easy to reinforce a selected area. After the creation, the user is directly able to modify the concrete cover or some of the other placement opportunities. Via the property window, the user can afterwards adjust the reinforcement based on new requirements. If the required changes are not part of the property of the surface reinforcement, the user can unlink the reinforcement and adjust it with the existing functionalities. For example, he can change parts of the placement via direct object modification. This is really intuitive and speeds up the work. With these extensions, complex shapes can be easily reinforced. My next topic are the improvements of fixtures. In 24, we started to improve the handling of fixtures and already received a lot of positive feedback. In 25, we finalized the work and implemented the placement of fixtures along surface, direct object modification to make adjustments on the placement intuitive and faster, and we added the possibility to create dimension points for associative dimension lines to increase the performance and the handling. With just one click, the fixture is transformed into the correct position based on any reference surface. The handling with handles is extremely intuitive and efficient for modification. Fixtures can be placed in a model or in a view or a section. We also introduced the local coordinate system for fixtures to explain the user the transformation on the reference surface. This example shows the benefits of unified navigation, because from now on users can directly rotate the element without using a separate mode. The next thing I would like to point out are the performance improvements of user-defined associative dimension points. Inside the definition of a fixture, the user is able to define his own custom dimension points. If they are available, the program does not need to calculate all existing edges of the fixtures. It will be directly offered the predefined points. This makes it much more efficient to select the right points for dimensioning an object. Let's speak about our new module Freeform formwork inside of Alplan Ultimate. With this solution, it is absolutely easy to create the formwork of balconies, spiral staircases, or unique prefab infra objects. I will show you how to assign formwork boards along any surface, create a substructure with an automatic juggling of the formwork boards, and the optimized export of formwork boards for a CNC machine. The first step is to assign formwork boards of existing surfaces under consideration of the neighbor board. That means the first selection of an area is mandatory for the area of the second selected board. In this example, the front sides are overlapping the predefined existing boards. In the next step, I will create a substructure based on a 3D geometry. In this example, I used a 3D modeling area to create a simple box. Here we can also see the new point recognition of the cursor. The user will be informed with a rectangle that he needs to have a more precise look on the situation to pick the right point. This avoids mistakes or wrong selection of points in difficult situations. To distinguish between horizontal and vertical boards, I used two different colors. The possibility to overtake any 3D component into a formwork board and the transformation back of single shuttering boards allows to find a solution for every situation. In the next step, the 3D components are transferred into a formwork substructure. To speed up the situation, I used some predefined boards for the rest of the solution. But you can also copy or adjust the boards via point modification to your personal needs. On the following, you will see how to create a juggling between the formwork boards. First decision of the juggling is to select a basic element, in this example the vertical boards, and then the horizontal boards to create the juggling. Now it's time for the intersection of the substructure with the rest of the existing formwork and the model itself. In the animation window, you can see the result of the juggling. This functionality saves a lot of time and makes the creation of any kind of substructure extremely easy and efficient. The next step is to create an explosion view of the attached formwork boards without the substructure. With the use of the object tree, manual shuttering boards can be easily switched off and the rest of the elements can be selected via area selection. The last step is the export for the data for a CNC machine. In my case, I just create all boards in the drawing file via a batch export to make the export visible for us. In the first step, for all attached boards, and in the second for the complete substructure. Regardless of the machine supplier, the data is prepared and optimized for an automated processing.
Thank you, Fabian. I'm really impressed by the ease and the efficiency with which engineers can create arbitrarily complex formwork boards based on any shape. To close out the session, can you give us an insight into the further planning? What can Allplan users look forward to?
Of course. The topic of sustainability and the associative openness to multi-material is a clear focus for our future development. Performance and usability improvements are also at the top of our agenda for next releases. The merge of Allplan, Frilo and Skia provides us a large opportunity for unique automatisms in the planning process of the future. So our users can look forward to a variety of exciting features in the future.
Indeed, very exciting times to be a user of Allplan. I think they're really looking forward to a lot of new solutions that they will face in the future. Thanks again for your contribution to today's event, and take care, Fabian.
Our next speaker at the Allplan 2025 launch event is Klaus. As the product manager for Precast at Allplan, Klaus brings a wealth of experience to the table. With a background in civil engineering, he spent 10 years working in an engineering office and another 8 years in a precast plant. Since joining Allplan, Klaus has applied his extensive knowledge first in support and since 2022 as a product owner in product management. Klaus, it's a pleasure to have you with us today to speak about how planning errors can lead to high costs and, in the worst case, injuries or even death. With our new tool, the planning can be checked for errors before export, and this risk can be significantly reduced. Klaus, can you tell us a little bit more about yourself, your profession, and your competence here at Allplan?
Yeah, hi Kelsey, thank you very much. As mentioned before, I worked many years with Allplan before I chose to take part at this great company. I started in the support team and cared about training of our customers, as well as doing implementation and configuration of Allplan at new customers. Since 2022, I am product owner of one of the both precast development teams.
Thank you, Klaus. What makes the features you are showing today relevant, and why should everyone look forward to using Allplan 2025?
You will hear in my demonstration some reasons what can happen if planning mistakes were done. Unfortunately, many offices are struggling with a shortage of skilled workers. Our new function provides extremely helpful support for less educated staff to identify objective errors in the planning phase and correct them before the parts are produced.
That sounds very promising, and I'm eager to see how this looks in the 2025 release, as I'm sure our customers are as well. So Klaus, please take over.
Okay, let's have a look to our new tool, Precast Data Validator. First, some reasons why we developed this tool. Errors in the planning process of precast concrete elements can have a significant impact on the entire construction project, both technically and economically. Let's have a look at some potential impacts. Structural integrity and safety. Errors in design, of course, can result in precast concrete elements not having the required load-bearing capacity. This can lead to severe structural problems such as cracking, deformation, or in the worst case, failure of the components. The choice of unsuitable materials can jeopardize the stability of the entire structure. This can lead to instability and the risk of collapse. Cost increases. Faulty concrete elements may need to be reworked on site or even completely replaced. This leads to considerable additional costs. The entire construction progress may be delayed. Time delays often lead to higher overall costs, especially if contractual penalties or extended higher costs for construction machinery are added. Logistical problems. Errors in planning can result in elements not being transported or installed properly. For example, incorrect dimensions or inadequate fixing points could make transport difficult and assembly unsafe. Problems can occur during installation if precast concrete elements do not fit exactly. This requires time-consuming adjustments on site and can disrupt the entire construction process. Quality defects. Planning errors can lead to problems with the surface quality of the precast concrete elements. This can affect both the aesthetic and the durability of the structure. If permissible tolerances are not correctly taken into account during planning, this can lead to difficulties in connecting the individual components and impair long-term functionality. Non-compliance with standards or regulations. This can have legal consequences and in worst case require the demolition of the faulty structure. Long-term effects. Design errors can cause precast elements to wear out faster or require more maintenance. This increases long-term maintenance cost. Errors in planning can impair the functionality and utility value of the structure, for example due to inadequate soundproofing or insulation measures. As a conclusion, we can say errors in the planning process can have serious consequences for a construction project, ranging from safety risks and cost increases to long-term damage and problems. Careful and precise planning is therefore crucial in order to minimize such risks. Now let's have a look how our Precast Data Validator can support you during the planning process. The data validator offers the ability to create additional checks during the planning process. These checks are completely free configurable up to your needs. All of these checks help avoiding planning errors, complaints from your customers, and even accidents in worst case. The results of these checks vary from information only up to prevent the data creation. All of these things ensure the planning quality and avoid costs. A closer look to the functionalities. The definition can be done in the precast catalogs. We offer a standard rule set for some standard checks, but with the formula validator, you are able to define all of the checks you need during your planning process up to your needs. We have the option to define fixed values, for example, for tolerances on our own site, where they are shown clearly beneath each other. We have several escalation levels from node only to fatal error, which prevents the creation of the production data. And of course, you can define rules for every precast element type separately. So far to this. Now let's jump to the program and have a look to the new functionalities in Allplan itself. So I prepared this little house here, and inside I created two precast walls. Let's separate the walls here. And you see, if you have a closer look, both of them are 2.60 meters in height. The left one is the smaller one, which has a weight 2.3 tons, and the right one has a weight of 6.4 tons. In addition to this, I created some checks in the precast data validator. One check which gives a warning if the wall height exceeds 2 meters, which is valid for both of these walls. And I created two checks. One checks if the weight is greater than 2 tons, which gives only a node. And the second check, if the weight exceeds the 4 tons, then it's a fatal error, and this fatal error prevents the creation of data. Now let's try to create the lists for these walls. If I could start a list generator for both walls, you see I get a message from the data validator, and you see at first you have a fatal error, data processing stops now, and the data is not created. And if you have a closer look to the details, you see for the wall number 1, which is the bigger one, the weight exceeds 4 tons, too heavy, cannot be lifted by the crane. For the other wall, you see it's only a warning that the wall height is above 2 meters and the weight exceeds 2 tons, and the program gives you the special messages for this. I also prepared a second check. I created 2 slabs here, and in these slabs we have some fixtures. And if we have a look in our data validator rules, I created a rule which controls if there are free fixtures on the drawing file. If I start the list generator again for these slabs now, you see I get a message that one fixture is not connected to a precast element, which maybe is an error. If we have a closer look why, it's very fast clear that by mistake I created this second fixture on the wrong drawing file. That's the reason why it's not connected to the precast elements. I think it has already become clear for these small examples that the new functionality is an important building block to support the draftsman in achieving the highest possible planning quality. And now, back to you, Kelsey.
A big thank you, Klaus. It's great to see the new features and functionality that Allplan 2025 will provide. Before you go, I have a few more questions, Klaus. What do you like most about the new version of Allplan?
I really like the many improvements that once again ensures that Allplan is an excellent tool for our customers for their planning tasks. And while our customers can now take advantage of the great new features in version 2025, we are already working on the first new developments for 2026 to make Alfplan even better.
Thanks, Klaus. How can the functionality you showed today have a positive impact on the work of the detailers?
Thanks to the data validator, users can approach their planning work in a much more relaxed manner, as they can rely on Alplan to recognize any errors that may have been made in the planning. This saves the user time for checking and still increases the quality of his work.
It's amazing to see the clear and long-term vision we have for Precast, especially for 2025. Thank you again, Klaus. We're looking forward to hearing from you again soon.